All right, stats here, 2-5 regression lines. This is actually something you've done before in Algebra 2. Even maybe in Algebra 1, talk about lines of best fit. So exactly what we're going to be talking about today. So a regression line is a line that describes how your response to variable y changes with an explanatory variable x. It is this equation right here, and this has to be an equation that you remember forever. Y hat equals a plus bx. And again, this is y hat. Y hat is the predicted value of y. So when you see this hat, right, this hat, think of the word predicted. So we're trying to predict the value of y from the explanatory x. Right? Now notice I say it's very similar to slope-intercept form, which is y equals mx plus b, but just notice that they've switched the y-intercept and the slope in x in our equation here. So notice the x goes last, here the mx went first. They also switched the role of b. So again, maybe I shouldn't have said that it's like slope-intercept form, but it really is, okay? So be aware, we'll talk about this all notes long. Extrapolation is an interesting idea here. Again, the root word extra, right? So an extrapolation is the use of a regression line for prediction far outside the interval of x values used to obtain the line, and it may not be accurate. So we'll look at an example in our first example of an extrapolation. But again, if you look at the graph, and the x value that you're provided is way outside what's on the graph, it's probably going to be an extrapolation. It probably doesn't fit the same trend as the regression line is showing. Okay? And again, it may lead to inaccurate results or predictions. Okay, example 1 here says, how much is that truck worth? Everyone knows that cars and trucks lose value the more miles they are driven. Can we predict the price of a Ford F-150 if we know how many miles is on the odometer? A random sample of 16 Ford F-150 Super Crew 4x4s was selected. The number of miles driven and price in dollars were recorded for each of the trucks. Here is a scatter plot of the data along with the regression line. Y hat equals 38,257 minus 0.1629x, where x is miles driven and y is price. Predict the cost of a Ford F-150 that has been driven 100,000 miles. So here's the scatter plot with our data. Here is the regression line, which is represented by that equation. They give us 100,000 miles. This is your x value. Your x value is 100,000 miles. So you're going to plug that in to this regression equation and see what the predicted miles is. So y hat equals 38,257 minus 0.1629 times 100,000. Okay, I'll take a picture of that and I will put that into Desmos graphing calculator and we'll see what that comes out to be. Okay, so let me escape here for a second. Let's go to Desmos graphing calculator. Okay, and here I go. So it is 38,257 minus 0.1629 times 100,000. And I got 21967. 21967. Sorry about that. Where am I going? Where am I going? Here. I got too many tabs open. Okay. So 21967. 21967. So $21,967. And again, if you look at the graph here, right? So that is 100,000, which is like right here. That's 100,000. And that would be the point right there on that line of best fit. So it'd be 100,000 and then 21967. Okay? So be aware of that. That is what we're finding, where that dot hits the line of best fit. Now, I do want to talk about an extrapolation real fast. So an extrapolation. So notice that extrapolation. Something like that. Oh, I can't spell right now. Extrapolation. Notice that the x-axis goes from 0 to 160. Now, what if I wanted to figure out how much a car or this 4x4 truck was worth after 300,000 miles, right? A value way past 160,000 miles. Well, let's plug it in. So y hat equals 38257 minus 0.1629 times 300,000. Let's see what we get here. Okay, so let me go to Desmos graphing calculator. Let's change the 3,000 to, or 100,000 to 3,000. And now look at that, negative $10,613. So you're trying to tell me that if I put in 300,000 miles, you get something like negative $10,316, something like that. Got to make sure it's right. 613. 613. So negative $10,613. Now, what does that even mean, right? I own the car. How could it be worth negative $10,613? That doesn't make sense. It's an extrapolation. It's an inaccurate response. If the car still drives, it's worth something above zero. Might be worth 10 bucks, but still, it's not going to be worth negative $10,000. And that's this idea that we have created a regression line using a strict set of x values. And this x value of 300,000 miles was beyond the interval used. So it's inaccurate. Okay. All right, great. That was objective one. Objective two is coming.